measuring angles and how that works. So when we look at how to measure angles, let me use this one. The one I have is too shiny. We use what's called a protractor. Okay, the only time I can really think about when you would actually pull out a protractor in real life is if for some reason you're making angles on like maybe a sketch and you want them to be exactly the same. Another reason why you might use a protractor specifically would be if you're in construction or welding or electrician and those kind of jobs. Okay, when you cut wood and pieces of wood, if you're making them come to a corner or you need to, have it turn, you do need to have that protractor out so that you are creating. Now, they have different protractors for carpenters specifically that are a little bit easier to use than this. And now I'm just talking because I can't find my pencil, so I'm just trying to waste some time here. Just going to go get a new one. Crushing it. All right, so I'm going to show you just quick how to use a protractor. So if I look at this, there's numbers. Okay, on the outside numbers, it starts here. It goes 0, 10, 20, 30, 40, 50, 60. It goes all the way up to 70, 80, all the way over here. On the inside are the other numbers that match. So it just depends on which way you're looking. In this one here, so I line up this bottom right here. When I look at this one, whoa, I did this one so good. I did it last class, and the one I drew was so bad. Okay, right now it's pointing. Is that angle going to be between 110 and 100 and 110 degrees, or between 70 and 80 degrees? Is it acute or obtuse? It's acute. It's less than 90, so we actually look at these inside numbers. So it's pretty close, 78. Okay, so if I draw one more. Okay, I got that there. All right, I'm going to do it upside down this time. So I'm going to put this little dot on that and make sure it lines up. And then, cool, 1 second. Okay, we're going to draw it up higher so that we can actually see what's happening in our lives. Okay, so there's my angle, there's my start. I put it there, right in that middle. Okay, now I'm going to find 70. This is 0, so I'm counting at 0, and I'm going to count up. So I'm using the outside this time. When I look for 70, 8. Here's 70, here's 80, so 78 is about here. We just make a little tick mark there, saying there's 78. And then we use the edge of this guy to draw the rest of it. And we don't have to draw it, we don't have to connect it all the way. We can just say that's 78 degrees. Okay, so that would be another way to show 78 degrees. Remember, we have this middle point. What do we call the middle point of an angle? Vertex. What point is our middle point here? It's called angle PTS. So the middle has to be, P? Not P.
No, T.
T. Okay. Did you say T over there too? I'm so sorry. Okay, good. And then it doesn't matter which one is P and which one is S? Nope. Can go either way. All right, I'm going to flip my page because I'm out of space here, and we are going to talk about a new thing. If you want to draw that, you can. Angles, it can go in any direction. You don't have to draw that. I was just showing you how to use a protractor. Very rarely are we using protractors in real life anymore, only for really like carpentry, electrician, construction, things like that. I mean, when I say rarely, I mean like there's a lot of people that have those jobs, so it's not super rare. But if for some reason you needed an angle, if you were even like designing a house, you would probably just use your computer program and you would type in what angle you need, and the computer program would just spit out the angle saying there's 78 degrees. Okay? All right, next thing we're going to talk about is congruent angles. We know what that word congruent means. What does congruent mean? Same or equal. Good, so we have two angles that have the same or have equal measurements, equal measures. Give me 2 more seconds here, sorry. Angles that have equal measures. No, it's a continuing, we started 1.5 yesterday, and then we're just finishing it today. So this was the start yesterday. I'm mad that you missed this 1.5 here. So we're just on the back page. All right, today we're going to start with, we're going to do 2 congruent angles. So angles have the same measure. We're going to try and make a 120 degree angle. So I'm going to start with on my first side, my first ray. If I want 120 degrees, is it going to be past 90 or before 90? Past. So here's my 90. Okay, here's my 180 all the way. Is 120 closer to 90 or closer to 180? Yeah, it's closer to 90. It's at 30 away from 90. It's 60 away from straight. So it does go in the middle, but it's going to be closer. It doesn't go exactly in the middle. It should be a little bit closer to that 90. Okay, and let's name this angle ANK. So A, N, and K. Okay, underneath it, I'm going to write out measure of angle ANK. So we use lowercase m for measure. Measure of angle ANK equals, we made it about 120, and how do we label angles? Feet, inches, degrees, seconds, degrees. 120 degrees. Okay, now we're going to try and make a congruent angle, but we're going to do it so it doesn't look exactly the same. Okay, so let's do it upside down. Okay, so I have my one side here. That's a really bad arrow. Pretend it's a good arrow. Okay, 90 this time is straight down. 180 would be straight across. So my 120, closer to the 90 than it is to the 180, but still nearish the middle. Okay, if that's not something you're good at yet, that's okay. This is still something that I'm only good at because I've taught this lesson for 6 years, and now I'm good at drawing these. If you look at my notebook from 6 years ago, my angles did not look even remotely the same. Okay, let's name this one CJE. And again, underneath it, I'm just going to write the measure of angle CJE. I literally told you not to forget it. Yikes. Measure of angle CJE equals 120 degrees. So because they match, we can say that they're congruent. And when they're congruent, we would say angle ANK. And then we say the congruent symbol. So the congruent symbol, remember, is an equal sign with a little squiggle above it. To angle CJE. All right, if you want to grab your colored pencils, I'm going to use blue and green today. There's one more part of this before we move on. One more. It's nice to see you. Thought you were gone forever. Monday? So sad. All right, so angle ANK is congruent to angle CJE. When we do that congruent, I'm going to use blue. When we did segments, I'll flip back here. When we did congruent segments, we had this little symbol showing us they matched. We had these tick marks. Okay? Samaya, get off your phone. Thanks. Okay, we had these little tick marks. When we do angles and we want congruent, we use these little swoops or arcs. So we put an arc in the middle here, saying that this measurement from here to here matches this measurement from here to here. And then we stack on top of it. If there's a picture with lots of those, we make them like rainbows. We add another arc to it, another arc, and you match the amount of arcs there are. So this tells us that they are congruent. Okay? All right, we have one more that's like our last kind of example, and then we just have one wrap-up idea here. We're going to talk about angle bisectors, or an angle bisector. Okay, we talked about that word bisector before. It has that prefix bi, like bicycle. What does bi mean? Two. So a bisector makes two sections. It makes two parts. And it makes it two equal parts. So I'm going to say something. And when I say something, it could be a line, it could be a plane, it could be a ray, it could be a line segment, it could be... I think that's it so far that we have on our understanding. So something that cuts an angle into two equal parts. All right, so we're going to do an example here. We're going to say segment JP. So when I write that segment JP, I can write J and P. What goes above it when it's a segment? A line with arrows?
No.
Nope, for a segment, no arrows. It ends. Good. So segment JP, we're going to say bisects angle TJM. All right, we're going to draw this over here. So I'm going to start with my angle TJM. It doesn't tell us what kind of angle it is. It doesn't tell us how many degrees it is. I'm just going to make a nice acute angle for us to work with. Kind of a bigger one, but still acute. A little less than 90 maybe. Okay, when I label my angle here, I always want to start kind of thinking about which one has to be my vertex. Where do they come together at? Yep, I know at what letter?
J.
J, good. Because it's the middle number here. Now, M and T can go in either way. Okay, I'm going to put M here because my brain would normally tell me that that's where T goes. And I want to make sure when I look back at my notes, I remember it's okay for it to be the other way. So M, J, T. When you pictured this, did most of you picture M up here and T down here? Or did you do T, J, M in your brain? Yeah, I did it the other way too. So I'm just switching it up just a little bit, just to remind ourselves. All right, now I have JP, segment JP. So segment JP, it has endpoints. I have J. Now I need to draw P so that it cuts this angle in the middle. Sophia, off your phone. Thanks. You have a concussion. You shouldn't even be on screens. All right. Probably. So when I draw this, I did a really bad job in my last one. Try and draw it so it cuts it near the middle. Nope, still was not good. Cool. Oh, no arrow there. It's a point. And it's JP. Okay, I did a really bad job there. You can tell my bottom angle here is bigger than the top angle. Whoops. It was supposed to go in the middle. I should have made it a little lower. But I can tell my reader that it bisects it, that these two parts are supposed to be equal. What's another word for equal again? Congruent. So I can use those little arcs to show that these are supposed to be the same. I drew this really bad. They're not the same, but they're supposed to be. So I'm going to do 2 arcs this time just to show you what that looks like. So I have an arc and an arc. So we can use 2 arcs there. Kind of creates that rainbow effect. And then when you go on the other side, it helps if you kind of stagger them. So try and make it a little closer or a little farther out. I do arc and arc. If you match it up, it just sometimes looks like it's one big rainbow. If you stagger it a little bit, you can tell they're different ones. Okay, and that tells my reader, hey, I'm sorry, I suck at drawing. These are supposed to be the same. Okay, so what's one of those angles that we just marked with that congruent sign? What's one of these small angles that is the same? Good, MJP, or we could have called that PJM, either one, is congruent to angle. What's our other little angle that was created? PJT or TJP. Good. If I know that this bottom one is like 44 degrees, how many degrees would the top one be? 44. So together, if I look at the overall angle, TJM, all together, the big angle is how many degrees? How did you get that? Good. 44 plus 44. All right, last thing that we're going to just talk about real quick. This is one that most of you know. We're just going to write it in our notes because sometimes when we do homework, our brain panics. Sometimes when we're in a test, we're like, I know this word, I should know this, and you feel like, oh my gosh. And it's just nice to have. We're just going to talk about classifying angles. And some of us just need those reminders of which one is which. And that's okay. So one way to classify angles is by saying it's a right angle. What does it mean when it's a right angle? Exactly 90 degrees. Okay? And remember, a right angle can go in any direction. It doesn't always have to be, I always draw an L because that's the way my brain works. But how do I show my reader that that's exactly 90 degrees? The little square in the corner. Good. Anytime you see that square, you know it's 90 degrees. All right, what's another word we use to classify angles? Acute. If I was an angle, I would be acute angle. Not only because I'm adorable and I'm cute, but because I'm really small. I'm very short, so I would be acute. Acute means it's less than what? 90. So acute means less than. If you imagine like cute little kids, you're cuter when you're younger, so you're cute. Okay? So that's a smaller angle. What's our word for when it's more than 90 degrees? Obtuse. Obtuse, some people use this when they're arguing with people and they're saying, I can't believe you are so obtuse. And when people say that, sometimes it's not always arguing. Sometimes you can say, oh, that idea is pretty obtuse. You're saying like they're applying a small idea to a wide audience. So they might be like stereotyping or they might be like overgeneralizing. So when you say you're so obtuse, that means like you're so just not even, you're widening it. You're making it like this huge idea when it like really this is a one-time thing. Okay, and then our last one that we often forget about, because usually you're taught these three together, the last one is straight. If it's a straight angle, it's exactly how many degrees? 180. That's okay. I understood where you were going with that. Okay, another word for this. Now, our textbooks call this. I can't imagine in real life when anyone else would say this, but another word we call this is opposite rays. And I'll show you why when we draw the picture. I showed it a little bit yesterday when we were talking about that 180. Our textbook calls it opposite rays just because it's a really nice academic way of saying it. If I have a ray, so I have an endpoint and it's going in one direction, and I draw a ray going the opposite direction, exactly the opposite, which way is that ray going to go? The other way. So it creates that nice, okay, again, my drawings are just not it today. Okay, but it creates that line. So another way to say it is opposite rays. Again, I honestly don't know when we would use that in real life and be like, oh, it's opposite rays. We would be like, it's straight. Don't know. Okay, that is it for notes today. You have the